So for my chapter 10 discussion, I will be doing question 9 from section 13.7e in the textbook. It's to verify the formula for higher degree Taylor polynomials works for first degree Taylor polynomials where L of xy equals P sub 1 of xy. The formula is given below, P sub n of xy, and it goes into the formula for higher degree Taylor polynomials. So we will be finding that for P sub 1 of x comma y, one second, will be, of course, the n's on our summations change. So I starting at 0, going into 1, and j starting at 0 and going to n minus 1. We go into the formula, the derivative, partials at point AB divided by I factorial j factorial. And this is just filling in the higher degree Taylor polynomial formula for n equals 1. So since I will begin at 0, I begins at 0 and continues to 1 and continues to 1, and j also begins at 0 and continues to just realized I made a mistake up here. That should of course be 1 minus I for all values I. We'll find that the possible values for I and j begin at I equals 0, j equals 0. Of course, I beginning at 0, j equals 0. I equals 0 again, j is going to increase. 1 minus 0 from I gives us 1, j equals 1. And our final value at I equals 1, j begins at 0, and we will have no other values because, of course, 1 minus an I of 1 makes us stay at 0. Therefore, we can say that P sub 1 of x comma y is equal to the derivative, where both are 0, of f of a, b. Both the partials will also be to the power of 0 over 0 factorial times x minus a to 0, y minus b to 0, plus, where I is still 0, j is 1, d of 0 plus 1 f of a b over dx to 0 partial of y over 0 factorial 1 factorial of x minus a to 0, y minus b to the 1, and the same thing again, but instead of y or j being to the 1, it is x to the 1. 1, 0, f, a, b over dx. So first dy to 0 over 1 factorial, 0 factorial, x minus a to the 1, y minus b will fit it in here to the 0. This, of course, will simplify down to simply be f of a comma b. X minus a to the 0 goes to 1, y minus b to the 0 goes to 1, 0 factorial goes to 1, everything to the powers goes to 1, giving us just f of a comma b plus the first derivative with respect to the partial y will give us f sub y of a comma b. Once again, x minus a to the 0 is 1, but now we also have the y minus b term, plus, same thing on the last term, the first derivative with respect to the partial x gives us f sub x of a comma b. Factorial, 0 factorial still 1, 1 factorial still 1. We can just get rid of these terms. X minus a to the first yields us x minus a. Y minus b to the 0 yields us 1. So we find that, of course, p sub 1 of xy equals f of a comma b plus f sub x of a comma b, simply rewriting the order and the partial with respect to y minus b, which, if we recall from the text, is equal to L of xy, where L of xy and p sub 1 of xy is the notation for a first-degree Taylor polynomial.